There are few topics in matrices and determinants which are just fabulous and beautiful in terms of the geometry and what actually they mean behind the scenes. One is the whole concept of matrix multiplication. And if you guys have seen my intuition videos on what multiplication means in terms of linear transformation, you'll appreciate that. And the second topic among the few within matrices that I love is a concept called inverse of a matrix. And again, if you really want to get fascinated and get your mind blown off, you should check out some of the intuition videos on what is so magical about inverse of a matrix. But let's start with the examination point of view on what inverse of matrix means. So let's take a quick analogy of in the number system. So let's understand what does the inverse of a number mean as an example. Okay, let's take that analogy. For example, let's say you have a number 5 and you multiply the number by its reciprocal, which is 1 by 5, right? What is 1 by 5? It's reciprocal of the number. So when you take the product of these two numbers, the number and the reciprocal itself, then the product is 1. And that's true for any number, right? If you take any number and you multiply it with its own reciprocal, the product is going to be 1. And in which case, both these numbers are called as inverse of each other, or in this case you can say 1 by 5 is inverse of 5, because when you take the product of this and this, the product is going to be 1, and hence 1 by 5 is inverse of 5, or you can also say 5 is the inverse of 1 by 5. It doesn't matter. And we can also denote the inverse with this kind of notation where you raise it to the power of -1. For example, if you have 1 by 5, it is as good as 1 by 5 raised to the power 1. And if I bring this to numerator, then I can say 5 to the power of -1. That's all this means. So this is the notation, and we can say that this is the inverse of this number. Similarly, not exactly, but if you draw an analogy for inverse of a matrix, what does it mean is, if you multiply two matrices, for example, let's say you have a given matrix A, and you multiply this by another matrix, which is a mysterious matrix. And if the product of those two matrices is a unit or identity matrix, if you don't recall, unit identity matrix is the matrix where all the diagonal elements are 1. In the number system, it's just numeric 1. But in terms of matrices, we need to think in terms of matrix notation. So when a matrix A is multiplied by another matrix, and if the product is a unit or identity matrix, then this another matrix, the another mysterious matrix, is called the inverse of matrix A, or you can also say that this A is the inverse of this matrix. Basically, both are inverse of each other, but for sake of definition, we'll call this new matrix as the inverse of A matrix, and this is denoted by this same kind of symbol. Although in terms of numericals, it actually makes sense where we say 5 to the power of -1. Over here, inverse of a matrix, it's just a notation. It's not actually A to the power of -1, because in the world of matrices, 1 by A does not exist. So there is no division of matrix concept. So it does not really exist. So it's just a notation where we say A inverse. It does not really mean that A to the power, but in terms of the effect that it has, it is meaning the same when you multiply this A into AI, or A into A inverse is equal to I, which is the unit matrix. That's what it means. So a simple concept where two matrices, when they're multiplied, and if the product is a unit or identity matrix, then those matrices are called inverse of each other, or you can think about one matrix as the inverse of the other matrix. That's what it is called. Now the thing is, how do you kind of memorize the formula for calculating the inverse? Before we jump on that, let's take a couple of visual examples on what it means. For example, let's say we have a given matrix 2 by 2 A, which is 4, 3, and 3, 2. And let's say we also have a A inverse matrix, which is -2, 3, and 3, and -4. Same 2 by 2, both are 2 by 2, okay? So when I take the product of this A into A minus and do the typical matrix multiplication, if the output is something like this, which is a unit matrix, then we can safely call that these two matrices, this and this, are inverse of each other, or you can say that this matrix is inverse of the given matrix A. Likewise, the same example over here. You have a given matrix A here, and let's say there is some mysterious matrix over here, A inverse, but let's say we don't call it A inverse. There's a mysterious matrix here, and when we multiply the both, we get as a unit matrix or identity matrix where all the elements on the diagonal are 1. In this case, this matrix is called as A inverse, and this is the A inverse of this given matrix A. That's what it means. A and A inverse. That's all it means. In terms of formula, this is a big concept because in a couple of videos from now, when we will be talking about solving simultaneous equations using matrix inversion method as opposed to the Cramer's rule, the first step is you will be calculating the inverse of a matrix given this formula, and hence that formula is important. And since we are going to memorize in this crash course, the way to memorize is for a given matrix A inverse or inverse of the matrix is given by 1 over the determinant of the matrix, which is kind of a pattern in everywhere where the determinant comes in the denominator and it cannot be 0. So 1 over the determinant of the matrix multiplied by adjoint of the matrix A. And if you recall, adjoint of the matrix A is nothing but transpose of cofactors. And what is cofactors? Cofactor itself is a signed matrix of minus, where you where you kind of take a matrix of minus, and if you remember, we alternate the plus and minus sign and sign it out, and whatever that new matrix is, that's called as a matrix of cofactors. And when you take the transpose of that, you get the adjoint. So again, what is A inverse? A inverse or inverse of a matrix is given by 1 over determinant, where the determinant cannot be 0, multiplied by adjoint of the matrix. And that's what there are a couple of examples here for a 2 by 2 matrix where you're taking the inverse of a matrix. In the denominator, you are taking a simple determinant where you are cross multiplying the principal elements and the diagonal elements other diagonal and taking the difference. And then this piece, if you see carefully, since it's a 2 by 2, if you see carefully, it's nothing but they have found the matrix of minus and they have signed it and then taken a transpose to find the adjoint of the matrix. This is the adjoint of matrix A, and this is the adjoint of this given matrix. That's what it means. So finding inverse of a matrix, only two things. When you multiply two matrices, and if those two matrices are inverse of each other, then the product is going to be an identity matrix, whether it's a 2 by 2 or a 3 by 3. That's number one. And number two is how do you calculate the inverse of a matrix? You calculate the inverse of a matrix by 1 over the determinant of a matrix multiplied by adjoint of the matrix A. That's all it matters. And we will see how to use this when we calculate the matrix inversion in a couple of episodes from now. That's a wrap up. I'll see you in the next episode.